Welcome to my page. So today we are looking at binary operations on sets. So to start with, we should understand what binary operation means. So the other name for binary operation is dyadic operation. Dyadic operation. So a binary operation is a rule of combining two elements to produce another element. You combine two to produce another one. So if the operation is binary on a particular set, then the element produced should belong to that particular set. For instance, we have set A with elements A, B, C, D, E, F, as you can see down here. We have a set A. A, B, C, D, E, F are the elements of that set. So if we take any two, or we operate on any two elements of set A, the result must be an element of set A. So for instance, if we operate A and B, we should get an element which is under set A. So A operates B must give us B, must give us A, must give us C, D, E, or F, any of those. Then such an operation is said to be binary on a particular set. So when we look at question 1, is this operation binary on set A? Then we have to check from the table here. Let us see whether this is binary on a set. So let us look at A operate B. So A and B, where are they meeting? They are meeting around B here. So meaning the set, the operation is binary on this set. So this is not enough. We can take other two. Maybe we say D star C. So we say D star C. So what is the result? D star C. We have D here and C there. They meet here. And the result is D, which is part of set A. Then this concludes to say this operation is binary on this set because it has agreed to the rule of binary operation on sets. So the answer for the first question is yes. This is the binary operation on set A because every operation or all the elements in this box are the members of set A. Therefore, it's a binary operation. Hope that is clear. We go to question 2. Show that the binary operation is commutative. So before we show that it is commutative, we have to explain the word commutative. It is actually a word that comes from commute. So to commute is to switch places. So I may be home, I may be in town. So I am switching. I can be here, I can be in town. Therefore, I can appear anywhere between home and town at any particular given time. So then I'm commuting. Therefore, what do they mean if they say the operation is commutative? Meaning when we operate on any two sets, the order does not matter. If we operate A star B, for instance, A operate B, the result should be the same as when we operate B, operate A. That is the meaning of commutative. Now, is this binary operation commutative? How do we prove, how do we show that it is? So for instance, we take A star B, which should be equal to B star A. So let us check the results for A star B. So when you look at the first row of A and the column for B, where they are meeting here at B. So we can also check the other operation after commuting. B is now the first one, then star A. So we start with B in the row of B, and in the row of A, where they are meeting, is also at B. So that has shown that the operation is commutative. We can take any other set of elements. We say maybe we take C star D, C star D. So C star D. We are operating on C operate D, which should be equal to D operate C, if it is commutative. So let us see the results. C star D. So we are in this row of C and in the row of D, where they meet, we have D as the result. Let us also check D star C. So in the row of D and in the row of C, they also meet at D. So let me just change the colors here so that you see properly. Okay, so D and C, they meet at D also, meaning the operation on this set is a commutative. Because when we commute the two elements, the two operations, we are getting the same answer. Hence, shown. That's how you show. Thank you. We go to the next question. Hence, fill in the blank spaces. So as we can see, there are blank spaces in this box. Let me just put the dots. Here is a blank, there. So we have about 1, 2, 3, 4, 5 blank spaces. So now we want to fill in. So how do we fill in? Since the operation here is commutative, we are going to use the rule of commutative. Okay. So this first one here, we have C operate F. So what do we get? C operate F. C operate F. We know that it's commutative, so it should equal F operate C. So what do we get? So we are looking for C operate F, which should be equal to F operate C. So let's go where there is F operate C. So F operate C, we get E. Therefore, even C operate F is E. So we're going to put E there. Okay. We come to the other. We have E there. The other box here, where there is a red dot. So we have D and E. So D operate E, which should equal E operate D. Therefore, we are looking for D operate E to put here where there is a dot. Now we know that D operate E is the same as E operate D. So let us look at where we have E operate D. It's here, E operate D. So we have B. Therefore, even D operate E is also B. So we put B here. We come to the other here, which is E operate C. So E is the C. So which should equal C star E. So what is C star E? C star E is C. Therefore, even E star C should give us C. So we are going to put C here. We are remaining with the two last boxes. This first one, there it says F star D. F star D, which should be equal to D star F if it is commutative. So what is D star F? D star F is E. So meaning if F star D is also E. So let us put E there. So the answer is E also. The last box is F star E. F star E, which should equal E star F. So what is our E star F? E star F, we have D. Therefore, even here, the answer is D. It is as simple as that. So we put D, our last answer. Then we'll have answered this question and we'll have scored the mark. Thank you for watching. Look out for the associative law on binary operations in my next video. Be sure to subscribe and share with your friends. Thank you.